Hello, in this video I am going to describe about another solid principle named Liskov Substitution Principle. The Liskov Substitution Principle states that an object or instance of a superclass can be replaced by an object or instance of a subclass without changing the behavior of the superclass, which means that we can declare a superclass or parent class, and the object of the parent class can be replaced by its child class, and we will get the expected output. Characteristics of the Liskov substitution principle. It follows open-closed principle, which means when new requirement comes in, you will create new child class for that requirement, and that child class will inherit the parent class to get the expected output. It follows separation of concerns. It follows single responsibility. Superclass object can be replaced by subclass object, and even replaced, we find the expected outcome. Advantage: separation of concerns, easy to maintain, easy to understand, easy to test, increased reusability. The base class remains clean. New classes for new functionalities follows SRP, and it follows OCP, open closed principle as well. Because each child class will have its own functionality, as it follows single responsibility principle, and for each requirement we will create new classes, and that new class will extend the parent class. Now I am going to show a brief example about the Liskov substitution principle. First, I am going to show you two classes that does not follow the Liskov substitution principle architecture. There is a cow class, and in the cow class we have a method which is returning this is a cow string, and there is a goat class which is returning this is a goat string by method getAnimal. So cow has its own method returning cow, goat has its own method returning goat. In the goat class, we are inheriting the cow as a base class. So the goat class is overriding the cow class's virtual method in the goat class. Now in the program implementation, if we replace the superclass object with the subclass as per Liskov substitution principle, the cow class should return the cow and goat class should return the goat. But if we replace the superclass object with the subclass, that is child class, it will return the goat. That means the cow object, which is supposed to return cow, it will return the goat, which is violating the Liskov substitution principle. I will show you the output. Here, from the base cow, we found this is a goat. So cow is returning goat. So the base class behavior has been changed, which is violating LSP. Now, in the different way, if I want to follow the architecture of LSP, I have created another base class, which is an abstract class, and it is containing an abstract method named getAnimal. You can also actually do this by using an interface. So public interface, domestic animals, and you will define a method there. You can do this by interface as well. So I am now actually doing the same purpose with an abstract class and abstract method. Abstract method does not have implementation inside the abstract class. It will be implemented in the derived class. So I have created a cow LSP, and it is inheriting the domestic animals abstract class and overriding the getAnimal method of the abstract class and returning this is a cow. In the same way, goat LSP is also inheriting the abstract domestic animals class, and it is overriding the getAnimal method of the abstract class and returning the goat string. So in the program, if I now replace the base class object, I mean the parent class object, with the subclass, which is also called child class, then it will return the expected output, as the domestic animals is replaced by cow child, the domestic animal object will return the cow. In the same way, if the parent class is replaced by goat, then it is returning the goat. So cow is returning the cow, goat is returning the goat. So which is actually maintaining the Liskov substitution principle statement. If I run this, we see that the cow LSP is returning the cow, goat LSP is returning the goat. It did not change the behavior of the base class because base class does not have implementation. It is actually serving the output of the expected classes. So I hope you have understood the Liskov substitution principle. In the next video, I will discuss about interface segregation principle. Thank you.